Hello everyone. Today I'll be walking you through the topic SCTP, Packet Structure and Transmission Mechanism. SCTP or Stream Control Transmission Protocol is a transport layer protocol that combines the reliability of TCP and the message oriented nature of UDP. Let's dive into its packet structure and how it handles transmission. So, this presentation focuses on understanding the internal structure of SCTP packets and how data is transmitted using this protocol. So we'll compare it with TCP UDP and highlight SCTP advantages in modern networking applications. What is SCTP? SCTP means Stream Control Transmission Protocol. It's a transport protocol on OSI layer like TCP or UDP. SCTP is a message-oriented, reliable transport protocol, and it was originally designed for signaling in telephony, but is now used in a range of applications, including web and IoT. SCTP offers some unique features like multi-streaming and multi-homing, which we'll discuss shortly. So, this is a simplified OSI stack in which session and presentation layers omitted. So, in which we can see logical communication between SCTP layers. Why use SCTP? SCTP has similar characteristics and application as TCP, but includes some important improvements. First one is no head of line blocking. TCP imposes a strict data ordering. However, if a user data message is lost during transit, all subsequent user data messages are delayed until the lost message has been retransmitted. Some applications do not require restrict ordering of messages. Example, application that exchange unrelated application messages could cope with out of order messages. Messages are simply processed as they arrive at the receiver, but TCP does not allow messages to pass each other. Second one is no stream oriented data transfer. TCP is stream oriented. This means that TCP treats data chunks transmitted by an application as an ordered stream of bytes, means octet in network speak. While this concept supports a wide range of application, messages oriented like email, character oriented like telnet, stream oriented like video, it is unsuited in most applications because this exchange application level messages. SCTP preserves application level message boundaries, thus liberating applications from implementing a framing protocol on top of TCP for delineating messages. SCTP simply maps application messages to chunks on the transit path and back to application messages on the receive path. Third one is multi-homing. Since TCP connection is defined by quadruple source IP, destination IP, source port and destination port, TCP does not support multiple homing, means use of multiple IP addresses on each side of the connection to allow multiple transmission path through the network, thus increasing reliability. SCTP has built-in support for multi-homing, which offloads high availability application from implementing this feature. Fourth one is certain protection against denial of service attacks. The connection setup of TCP allows denial of service attacks, particularly SYN attacks. Each time the TCP layer receives SYN packet for setting up a new connection, it allocates a data structure for storing connection parameters called transport control block. Flooding with a high number of such SVN packets may lead to memory exhaustion. SCTP implements a procedure to avoid or at least make it more difficult for an attacker to launch a connection denial of service attack for the connection setup which state cookie. Main features of SCTP. First one is multiple data stream support. Supports for multiple logical streams of application messages, ordering of messages within a stream, avoidance of head of line blocking. Second one is message oriented data transfer. Transport of user data as a messages, preservation of application level message boundaries. Third one is multi-homing for network redundancy. Use of multiple IP addresses for SCTP endpoint to allow transmission of data through different network paths. Denial of service attack protection. Some measures to protect against denial of service attacks such as connection setup flooding. Fourth one is fragmentation. detection of path MTU and fragmentation of data chunks to fit into the available path MTU. Fifth one is error correction, in which acknowledged error-free, non-duplicated data transfer. And sixth one is congestion avoidance. Similar functionality as in TCP to avoid congestion to build up in the network. This is a SCTP packet format. SCTP packet header and chunk format. The SCTP header contains only a limited set of fields. More SCTP control information is contained in control chunks that are bundled with user data chunks into the SCTP packet payload. So, uh, this is the overall structure of an SCTP packet. It includes a common header containing the source destination port, verification tag, and checksum. And here one or more chunks which may contain control messages or user data. The chunked architecture makes SCTP flexible and efficient. SCTP data chunks format. User data chunks carry application data along with some chunk and stream management data. So here we see user data sequence of stream as payload protocol identifier, stream identifier, stream sequence number, TSN, chunk length. So here we can see that data chunks are there, in which it includes U-bit, B-bit, E-bit, stream identifier, stream sequence number, payload ID, user data. So U-bit means if set to 1 indicates that this is an unordered chunk. Unordered chunk are transmitted and sent to the receiving application as it is without reordering based on the sequence number. B-bit, it begin of fragment bit. If set to 1, this is the first fragment of a large fragmented user data message. E-bit means end of fragment bit. If set to 1, this is the last fragment of a large fragmented user data message. Stream identifier. It identifies the stream to which this chunk belongs. Stream sequence number. Its sequence number of user data within the stream. In case of fragmentation, this number is identical for all fragments. Payload, which identifies the upper layer protocol, example HTTP. User data, application user data. SCTP chunk types. SCTP packet chunks are either data or control chunks. These chunks may be bundled in an SCTP packet in any order. So here are the chunk types, its ID and description. So we'll see one by one. First one is data. Here ID is 0 and user payload data. Init ID is 1 and which is used for the initiation of an SCTP association. Init acknowledge, which initiation of acknowledgement. SAC, selective acknowledgement of data chunks. Heartbeat, heartbeat request for probing reachability of a peer transport address. Heartbeat acknowledgement, heartbeat acknowledged. Abort, used to immediately close an association. Subsequent control chunks are ignored by SCTP. Shutdown, used for gracefully shutting down an association. Shutdown acknowledge, shutdown complete, acknowledge receipt of shutdown acknowledge and completion of shutdown process. Error, which is used for reporting an error condition to the SCTP peer. An error chunk may be followed by an abort. Cookie echo, chunk containing the state cookie in the association setup. Cookie acknowledgement. This is the last chunk type. These are the applications of the SCTP. First one is telecommunication signaling, voice over IP, WebRTC data channels, LTE, 4G, 5G networks, industrial control system, military and emergency communications, high availability systems. To summarize, SCTP provides a rich set of features for reliable message-oriented data transmission. Its packet structure and chunk-based design give it flexibility, while features like multi-streaming and multi-homing makes it resilient and efficient. Thank you for watching. I hope this helped you. Thank you. Thank you.